Light is the reason we are able to see anything at all. Light moves as a wave, bouncing and reflecting off objects so we might see them. Without it, we would be in complete darkness. But if light reflects off everything, then why does a mirror look so different than a wall? When light from the sun hits an object, one of several things can happen. Light can bend and move through the material, which is called refraction. Or light can bounce off the material, which is called reflection. The reflection of a wave is simply a process by which a wave, whether light, sound, infrared, or radio waves, hits an object and bounces off of it. But this reflection looks quite different for a mirror than it does for a wall. When any wave, including light, hits a surface that is opaque, the light will mostly reflect off that surface. The law of reflection tells us how it bounces off that surface. When a wave is moving toward the surface, it's called the incident ray. When it bounces off, it's called the reflected ray. If you were to draw a line perfectly in between the two rays, the law of reflection tells us that the incident angle is equal to the reflected angle. When you look in a mirror, what do you see? As long as the mirror is flat, the picture is nice and clear at the correct size. All the parts of you are in the right place. This is because of the law of reflection. But does that mean it only applies to mirrored surfaces? Reflection from the surface of a mirror, or any reflection where all the light rays reflect off a surface at the same angle, is called specular reflection. But in fact, the law of reflection is always true. When you go from a mirrored surface to a regular surface, it isn't the law that changes, but the surface itself. Take a look at the table on which your computer is sitting. Run your hand across it. Does it feel smooth? Although something might feel smooth to our hands, the surface contains millions of tiny imperfections. Because of those imperfections, a light wave doesn't hit the flat surface we see. Most of the time it hits an imperfection, and those imperfections could be pointed at any angle at all. Therefore, light waves hit different imperfections and bounce off at different reflected angles. This is called diffuse reflection. Specular reflection and diffuse reflection are two types of reflection. The more shiny and mirrored a surface, the more specular reflection occurs, and the more dull a surface, the more diffuse reflection occurs. Sound is also a wave, and can therefore reflect in the same ways as light. Often the reflection is diffuse, but with smooth walls in an auditorium, some strange effects can occur. In the Cathedral of Agrigento in Sicily, it was discovered that confessions could be overheard from 250 feet away, provided you stood in exactly the right spot. Words spoken at the opposite side of the room could be heard clearly, due to the sound waves bouncing off the walls of the cathedral. The architect had unfortunately designed the cathedral as an elliptical room, and due to sound waves following the law of reflection and bouncing off the walls, if two people are standing in two particular locations, they can have a conversation as if they were standing next to each other. The vibrations in the earth that form earthquakes are also waves. While you might think that being closer to an earthquake is the only way to feel the vibration strongly, due to the reflection of waves, seismographs can detect earthquakes at a great distance. When an earthquake occurs, the vibration moves through the earth in every direction, creating waves in concentric circles. But the waves also go downwards, heading under the earth. When those waves hit the Earth's core, they can refract or reflect, and then bounce to other parts of the Earth's surface. In fact, an earthquake can on occasion be detected at almost the opposite side of the planet. It is this reflection that first allowed scientists to determine the structure of the Earth, with its crust, mantle, inner core, and outer core. When we listen to the radio, that signal can be transmitting from a great distance away. So how does it get to us? Radio signals are also waves, and those kinds of waves can bounce off the ionosphere, or upper atmosphere, of the Earth. If they didn't do this, you would only be able to listen to the radio if you were in direct line of sight with a transmitter. Waves, like light, usually travel in straight lines. Waves are everywhere in our lives, from light and sound to radio and infrared. Understanding how waves reflect was vital in developing many of the technologies we use today, And it all comes from the basic law of reflection. The law of reflection says that incident angles and reflected angles will be the same, which is true even on imperfect surfaces.